Scientists now say there's a 90% chance we could see a black hole explode within the next decade. Not only would this confirm one of Stephen Hawking's most famous predictions, it could reveal every single particle in the universe. This isn't science fiction. This is real physics, and the countdown may already have begun. Most black holes form when massive stars run out of fuel and collapse under their own gravity. These monsters are stable, extremely heavy, and swallow everything around them, even light. But physicist Stephen Hawking showed in the 1970s that black holes aren't entirely black. They can slowly leak energy as radiation, what we now call Hawking radiation. Over unimaginable timescales, this can cause a black hole to shrink, heat up, and ultimately explode. Now imagine a different kind of black hole, not born from stars, but from the violent chaos of the Big Bang itself. These are called primordial black holes, or PBHs. Unlike stellar black holes, PBHs could be tiny, some no bigger than a mountain or even an atom. And because they're smaller, they'd be hotter, radiating particles faster as they shrink. Eventually, they could explode in a burst of energy detectable from Earth. For decades, physicists assumed the odds of seeing such an explosion in our lifetime were virtually zero, maybe one every 100,000 years. But new research from the University of Massachusetts Amherst, published in Physical Review Letters, challenges that. By rethinking assumptions about black hole charge and incorporating a dark electron in their models, the team concluded something radical. There's now a better than 90% chance of seeing an exploding primordial black hole within the next 10 years, and our current fleet of space and ground telescopes is already capable of catching it. An exploding PBH wouldn't just be a cosmic fireworks show. It would release a definitive catalog of all subatomic particles in existence. That means confirming known particles like quarks, electrons, and the Higgs boson, potentially detecting dark matter particles for the first time, and maybe even uncovering particles we've never imagined. In other words, this could answer one of humanity's oldest questions. Where did everything come from? What would we see? As PBHs shrink and heat up, they emit Hawking radiation in a runaway process. More particles, more heat, until boom. That explosion would produce a flash of gamma rays and high-energy particles. Instruments like NASA's Fermi Gamma Ray Space Telescope, the Cherenkov Telescope Array, and even Earth-based detectors could capture the signal. Of course, this is still highly controversial. Many physicists argue PBHs may not even exist, let alone explode on human timescales. But questioning old assumptions is how science moves forward. And this new model opens a window we thought was shut. If it happens, it would be the first ever direct observation of Hawking radiation. It could revolutionize physics, rewrite our understanding of the universe, and perhaps even point the way to a theory of everything. So, what do you think? Are we about to witness a black hole explode in our lifetime? Or will this remain one of physics' great untested theories? Let me know in the comments, and don't forget to subscribe for more deep dives into the mysteries of the cosmos.